I'll be drinking some water, and we'll be talking about some blue team logging and how, as a red team, we know pretty much everything that happens during the competition on the blue team boxes. So this is our basic structure that we're going to be talking about today. So we have our wonderful blue teams over here, and then we ship a lot of data to Chainsaw, and then we ship that data after we parse it over to Sawmill. And then we also get all of our beacons that they track at Pwnboard, and I will do a little demo with it later. But unfortunately, all of my demo boxes got deleted at like 3 a.m. this morning. So thank you, UB. Yeah, we start with our blue team boxes, and on those blue team boxes, we deploy different tools that will generate logs, whether they're beacons or whether they're custom logging tools that we drop. And then they ship those logs to logging aggregators, and all of our beacons will call back to a C2, and the C2 reports to Pwnboard, or if it's a customized logging tool, it sends their logs to Chainsaw. And then both of those logging aggregators will ship their logs to our elk stack located here at Sawmill. So this is a basic structure, and we're going to dive into it. So yeah. So currently, we have logging capabilities for beacons, for firewall rules, and for credentials. And at the moment, not all 3 of them are combined in the same space. We're building towards that, and we're getting closer to having all of those in the same location, just for ease of access with the red team. This is Pwnboard right here. This took the screenshot last night. Right now it's all blue because I think UB destroyed their infrastructure for reals this time. This is a screen cap of all of our firewall rules reporting back to Chainsaw. As you can see, Chainsaw is our little elk stack thing right there. And then we have all of our wonderful credentials happening right here. And eventually, all of these logs will be reported to Sawmill in the same place, and it'll be really easy to go and see. So right now we're talking about Pwnboard and kind of like how it works. So all of our agents that we drop on blue team boxes will send a post request to Pwnboard every time they call back. And usually the way this one works is like they will call back to their C2, and the C2 will relay that information to Pwnboard. And so when you really look at like the specifics of Pwnboard, the screenshot's really small. But if you guys go to pwnboard.win, you can go and see all of our tools kind of calling back and kind of updating this logging aggregator. So Pwnboard on the back end, when it receives a request, it'll update the JSON square with like the name, how often it called back, and then it'll format that packet into a syslog and ship it to Sawmill. And when all of that is done, and we've got all of our beacons deployed, Pwnboard gets turned red, and we know that we have access to every single box via our beacons. So one of the cool things that we have both Pwnboard is easy integration into tools. We have Bash, Golang, and Python libraries that people can just drop into their C2 and send like their logs to Pwnboard, which I think is fantastic. Talking about credentials at this point, I know less about this because I have not specifically worked with them yet, but we have a couple of tools like WinFilter and Retriever that will collect the passwords and collect the credentials during credential change operations. Like we'll hijack passwd, and we'll hijack like the Windows process to change passwords, and we'll ship those passwords to our centralized Discord server, and that's how we get passwords from blue teams. In the future, we'll also be shipping those to Sawmill so that we can get all that information in the same place, and it'll be really cool. So have a little crowd interaction. What does IP table stack L do? Anthony. Jack, what does IP table stack L do? Yeah, it does, precisely. Okay, good job. Now, what can I do if I had that information, Ishan? What do you think I could do with IP tables information? I could flush the firewall rules if they had specific things blocking my traffic. This is true. What else could I do? I could know if a team is doing well, if they are, if they're writing lots of good firewall rules. I could see, like, if their team is going to do better or worse than another team is not writing any host-based firewall rules. And Zach, how do you think I could abuse this information? Any guesses? No? Okay. Well, I can take this information and I can try to keep the competition like fair and balanced for everybody, and I can just the more information that I have about a team, the more that I can do with that team. So if a team writes in like an incident response report that they blocked red team traffic by hardening their web services and locking down like port 80, but I have their IP tables information. I can verify that they didn't block our traffic at all, or I can see that they did, or whatnot. So IP tables is pretty cool, and knowing about what the blue teams are doing is also really cool. So we have a tool called Campfire that sits on the blue team boxes and reports IP tables informations up to Chainsaw. And I like this picture a lot, so that's why it's on this slide and this slide. So Campfire is a Go binary, and all it does is just run IP table stack L, but in a more separated format, and it just gets different sets of information. It collects all of the information from IP table stack L, and it ships it in post requests up to Chainsaw. So this is most of the source code for this Go tool. So starting over here, we run this wonderful command, and we get all of the routes that are hard coded into the system, and then we come over here, and we run this command to get any information that was saved into IP tables, which kind of gets like the big tables. Who knows what the big IP tables are? Evan first. Okay, give me one. Mangle table. Philo. Nat table. Okay. Enzo, what's on the IP tables table? It's a chain. You're close. Good job. I should give an IP tables talk sometime. Math. What's on the table? Filter table. And is there any more? I think there's one more. Yes. Raw table, I believe. So we can little sidetrack on the IP tables. With those 4 tables, the Mangle table, the NAT table, the filter table, and the raw table, you can pretty much alter any single aspect of a packet that comes in to the box. And so to kind of offer some organization into writing firewall rules, these tables exist, and we get all the information about the tables with this command right here. And we run this command to get any specific hosts that they hard-coded into an etc hosts file, which is great if we want to say you want to pi-hole github.com. That's pretty cool. We can do that with etc hosts. And then we put all of that stuff into a nice format using JSON stuff, and then we ship it using a post request to Chainsaw. Yeah. And then we flush our rule we make a rule to allow our traffic out, and then we send our data, and we drop the rule so that they can't tell that we were there. And that's pretty much how Campfire works. Any questions on this? No questions. Fantastic. Cool. So moving on to Chainsaw. And I'm sorry, this is an angle grinder. It's not a chainsaw. This is the best that Microsoft AI could do. I'm a bit disappointed in myself, but this is a great picture. So it's in the slide deck. So Chainsaw is a Flask app. Means that it's written in Python, and it's pretty extensible. It's really easy to use. And with it, we create endpoints for all of our logging tools. So if somebody wanted to create like a custom log tool that wasn't something that we already have, such as Campfire or Scavenger Pro, they can just implement their own endpoint on the Flask app just by like adding like this right here, and then doing some stuff with it like this, and then it's pretty simple. So what it does is it will only accept post requests to Chainsaw, and then it'll parse that and create a syslog, which will then ship using FileBeat over to our elk stack. So Chainsaw takes our JSON data, formats it as a syslog, sends it off to be visualized in our elk stack, and it's pretty cool. Though it's a bit annoying to use if you don't know what post requests are, or if trying to debug. Does anybody know what like the default action is when you like go to a browser and you try to open a tab? Like what type of header you use? Like sorry, not header. What kind of request? It is a GET request. So when you're trying to see like what's happening, like if any of these endpoints are actually working, and you go to use a browser, it doesn't work. I learned that one the hard way. So don't do that. You can use curl tag x, then post, and then you can curl the address if you want to do that. Yeah. Any questions about Chainsaw? Cool. Sawmill, our wonderful elk stack. So, this one has, yeah, so Sawmill is our elk stack. Elk stands for Elastic, Logstash, and Kibana. And basically it's a way to aggregate log data and then visualize it in pretty formats. And we have a customized elk stack that was, and like all these tools actually were written by a person named Jim Mascaloni. And he's really smart. I look up to him as a red teamer. He's it's like 1 or 2 years, graduated now. But yeah, all the stuff is cool. The elk stack is used to visualize all the data that we get. And some of the stuff that we can see through the elk stack is the hacker meter. And we can see like how many callbacks we have every 2 minutes. During the competition, we were up to like 189% hack meter. Because I took this screenshot last night, and UB had destroyed about half their teams. We're down to about 51%. But we get some really cool visualization through this. We also have a wonderful access over time graph, and we can see like how many callbacks we're getting every like 2-3 minutes, I think. So in this graph specifically, like this is when we started it. This was like Thursday night, and then this was during the competition. Then all of the Windows hosts got redeployed right here, and then this, all the Windows hosts got redeployed right here, and this was during the competition, and this was after the competition when teams, we turned off our own C2s and our callbacks kind of decreased, and then last night they destroyed half the teams, and we lost pretty much all our callbacks. So this is just a really cool graph to see how the blue teams are doing in blocking our traffic, to see if our callbacks are still working, and just to kind of visualize the data in a fun way. And then this is a pretty nice slide. We've got our hacker meter over here, we've got a graph up here, and then we have a nice pie chart of that creates a percentage of all of our tools that are calling back. So we have Bravo 6, which is Brad's wonderful C2. We've got Hivemind, which is our team server. We've got Nginx Worker and Meep Shell and some other tools in there. And all around, it's cool visualization. So some future ideas to enhance our blue team logging. I'd love to get some Windows passwords and some Windows firewall rules written up and used and kind of shipped up the server. Same thing with pfSense. As I said earlier, like the more information that we know, the better we can do as a red team. And if we can see if a blue team is making PF-sense firewall rules, we can go harder on that team. Because if they're not really writing any Windows firewall rules, changing the Windows passwords, then we can maybe go give them some help and kind of teach them a little bit. Currently, our password collectors don't ship to Sawmill, but we're gonna work on implementing that in the future and getting them also from Discord Go into Sawmill and having it be amazing that way. Some other tool ideas that I have was setting up package logging, because you can add customized scripts that can run when you run apt-get or yum-get, well, yum-install really. And so if we can set up package logging, we can see if teams are installing new services, if they're installing old services. It's just more information. And then we also get some service logs. So like obviously there's scored services during the competition. We can send those service logs to our Elk stack and see what services are up, what services are down, how they're doing overall, and just kind of get some more information about the teams. Some more back-end stuff that's not really a new tool, but just to make this all easier. I'll be writing more documentation on it and creating easier ways to test it and debug the programs to make it easier to deploy in the future. These tools were written like 2 years ago by an alumni now, and the documentation is all right, but it's still a lot of guesswork, and it's a lot of, am I doing this correctly? And the process could be a lot smoother, and it could be kind of up to date with our current deployment methods using Ansible. And so one of my high priority projects is running a better deployment for these tools and adding some more documentation. And so if I've said anything in this presentation that has interested you and you want to help me or come on board with some logging stuff, let me know. Be glad to work on a project with anybody. Any questions? And then I thank you for your time and for answering my questions. Have a great afternoon. Have a good weekend. I'll see you all tomorrow. There's too many. There are too many.
Just real quick, for the WISA CTF, as soon as the RADSIC meeting is over, please head up to the club room. Chris does have a few words before